Question 1. Which type of internal capacitance dominates when a p-n junction is placed under reverse bias conditions? Under reverse bias, the widened depletion layer acts as a dielectric insulator between two conductive regions, producing junction, or depletion,
Question 2.
capacitance. How does increasing the reverse bias voltage change the junction capacitance of a diode? An increasing reverse voltage widens the depletion width. Since capacitance is inversely proportional to plate separation, the junction
Question
capacitance
3.
drops. Which specialized diode is structurally optimized to act as a voltage-controlled variable capacitor? Varactor, or varicap, diodes are engineered specifically to exploit this reverse bias voltage-dependent capacitance for electronic RF tuning. Question 4. Which capacitance mechanism dominates when a p-n junction is operating under forward bias conditions? In forward bias, the sharp increase in injected minority carriers momentarily stored near the edges of the depletion zone gives rise to diffusion capacitance. Question 5. How does the value of diffusion capacitance scale with the forward bias current passing through the diode? Because more current means a greater density of injected charge carriers tracking the signal, diffusion capacitance scales directly and proportionally with forward current. Question 6. What basic physical metric directly dictates the magnitude of a diode's forward diffusion capacitance? The average lifetime of injected minority carriers determines how long charges linger before recombining, directly scaling the stored charge and diffusion
Question
capacitance.
7.
What transient time parameter limits how fast a forward-biased BJT or diode can be turned off? When switching from forward conduction to cutoff, the diode remains highly conductive for a brief period called the reverse recovery time while stored charges are cleared. Question 8. What happens to the high-frequency impedance of a p-n junction due to its internal capacitances? As operational frequencies rise, capacitive reactance drops, shunting high-frequency signals across the junction and degrading the device's switching performance. Question 9. In an asymmetric p-n junction where the p side is much more heavily doped than the n side, where does the depletion region expand most? To secure charge balance across the junction, the depletion layer must penetrate much deeper into the lower concentration, lightly doped side. Question 10. Which manufacturing process introduces gold or platinum atoms into silicon to reduce carrier lifetime and speed up switching? Introducing heavy metal impurities like gold acts as a lifetime killer, establishing deep-level traps that accelerate recombination and speed up switching times.